All right, let's do some past paper today. So the first question we have is a vectors here, OA and AB. So which means that an origin goes through origin, and so we have A is here, and then AB is the other one. So A and B is like we want this line. So we want a starting point, a direction vector to get through those. So what we have here will be x, y, z equals to a direction vector, which is with respect to O. So this would be the point, 2, 1, 3, plus t, the direction vector is just no-brainer with those. All right, you will be able, if you like, you can write it into a horizontal form, which is like 2i plus 3, 2i plus j plus 3k plus s, or t, let's stick with t then. T, I plus 3j plus k. I personally like this one, but then you should be able to know this as well. And then we're moving on to the next one, will be B. So B will be vectors perpendicular to this one, which means that this vector and the direction vector, remember when we have perpendicular, which is the angle, have to be a direction vector to move it through. So we have 2PO 0 dot 1, 3, 1. Make sure using the direction, the moving one. This is a reference vector, a position vector. So this should be equals to 0. So we have 2 plus 3p equals to 0. So p should be equals to negative 2 plus 3. Nice and easy. All right, the next question, we will have the area under the, we have a curve, we have a limit here. So we just have to integrate this bit. And so A, which is integral 6x squared minus 3xd. Since we have A integrating a xn, dx should be equals to a n plus 1 xn plus 1. So what we're going to do is like we just throw it to the front, 6 over 3 x. I'm writing more step than I need to. So 3 over 2 x squared plus c. All right, just in case, although this will be fine here, but I'll leave it. So the area enclosed by this line, so B will be 2, 1, 6x squared minus 3x dx. So we will have 2, forgot to simplify that one. All right, so the 2x cubed minus 3 over 2x squared, and then we put 2 and 1 in. So in that case, we will have 2 times 8, 16 minus 6, and then minus the second one is 2 minus 3 over 2. That should give me 19 over 2. Nice and easy. All right, this is a fun question with stats, which always gets to the student because seems to be easy, but always got that through. So we need to find a number of data. We got the sum and the mean. So we have 800 divided by n should be equals to 20. So we throw it to the other side. N should be 40. Nice and easy, no brainer. And then the next set is getting harder. Right? The standard D is 3, and each data multiplied by 3. So the new mean, we're just multiplying, nice and easy. So we have 20 times 10 become 200. Nice and easy. And then B will be a bit, B2 will be a bit tricky because the new variant. So we have 3 squared, get it back to the variant, and then times 10 squared because each of the data multiplied by 10. So now we got 900 as the variant. Now be careful, the question is just asking for variant and they give you standard D. So make sure you square it and leave it as it is. Don't do too much on square root data because that becomes the standard D. And this is our. All right, so we have an arc and sector question here. So we got point A and B with isolate, and then arc length is 6. And then the area shaded is 12. So all we got is we just look through the data booklet. We got our area 1 over 2 theta r squared equals to 12 and theta r equals to 6. We can put theta in, so we have theta equals to 6 over r and put it back in here. So we have 1 over 2, 6 over r times r squared equals to 12. Cancel that out, so now we have 3r equals to 12, r equals to 4 cm. Hold on, does that for theta? No, and then I'm done. Nice and easy. All right, so this is a function question. So we are reflecting and we are sketching x minus 1, x negative x. So it's flipping on the x-axis. So our question is here, originally here. Yeah. So that will be getting through here, because this is like that, and the other side is the other way. So this is the answer. This is the original. And then moving on, there's another function they have to switch it a bit. So first of all, we know that it's flip it upside down here from originally here. So flip it upside down. So we will have a negative a. And then we think about that, it's stretched from 1 unit to 2 units. So it's stretched by 2. So it's negative 2 f x plus b. Then we're going to think like from originally, the vertex, the turning point is 0. Now it's 1. So it's moving right. So it's minus b. So we will have a function like this, which means turns out to be e equals to negative 2 and b equals to negative 1. Remember, do not write here, so you should write it on the question here, the lines here. That helps the examiner to go through those, but that's how I show you. All right, this is a tricky question I really like, because it's not only calculating your number of roots or something, but it also requires some of the concept thing. Yeah, that's the difference between 6 and 7. All right, so this time we say number of roots. Whenever you see number of roots, you have to consider the discriminant. So first of all, I write down the discriminant equal to b squared or minus 4ac. All right, simplify a bit, you can become minus 16p. All right, so we got fx equals to 0. That's how we go through those. And then now, if we throw this, if it have more, find a note, and then because if we, p definitely is not equals to 0. So p is a value. So, which means that q is something related to it, and then therefore we will have the bit of both. So we will have, because the 16p squared always bigger than 0. All right, sorry, minus. And then this has a positive, and q, no matter q is positive, negative, or 0, the whole thing is still positive. Therefore, q squared plus 16p squared always bigger than 0. And which means that f definitely has 2 roots. All right, so this is how we get through those. Pretty easy, but then you have to like click, get that click in the exam. We are getting to the question 7 with a new pencil. Yeah, I like this one. Okay, so we have the log there. So we have to find out d, is it? So I like this question because it also requires students' knowledge on the summation. So we talk about that later. We go through the d first. Arithmetic sequence, so which means that there's a common difference there. So definitely in mind first. And then we have u1 and u2. So d should be equals to u2 minus u1. That gave us log CPQ minus log CP. Minus become divide at log. So we have log C PQ divided by P. So that ends up, let me do some cancelling. That ends up log CQ. Happy? Okay, and then now we go to the summation. Summation means that a sum of an expression here. And this is the starting, this is the ending. So which means that it's actually u1 plus u2 plus up to u20. Which actually the question is asking you for the sum of the first 20 terms. Now we need our d, we need our, with these information there, we'll get it. So u1, because it's equal to log 1c, p becomes c squared. So that gave us 2. And d is cq there, so we have log c, q3 give us 3. Now with the formula from the data booklet, you will have S20 equals to 20 divided by 2, 2u1 plus n minus 1d. And then after you calculate that a bit, you will get 20 And that's how we do it. All right, so this is a long question paper here. Remember, do not write solution on this page. I write it here just to help us to see the question, read the question carefully. But then remember, please, if you're in the exam, do not write on it. Write on the single line paper given. So first of all, this guy come to school before, leave home before 70. It's like, so not leaving later than that is 1/4. And then he leaves home before and late is 1/8. And not late should be a complementary event and so on. So we got the 3 points, nice and easy. And then moving on, we have so find the probability before and is late of work. So it's before and late. So we have 3/4 times 1/8 give us 3/32, basic fraction. And then moving on, we will want to have it's already late for work. So it's either this or this. So we need to add this side as well. So it's 3/32 plus 1/4 times 5/8. So 32 is 5 and that become 8/32. Simplify that is 1/4. Nice and easy. And then now, given that it's going to work and then he is already late. So it's a conditional probability. So what we have here is like given is late and then it's before. So we need to do that is just find a bit of those. So it's before intersect late over probability of late. We have that on the top, so we have 1/4 at the bottom, and then it's these two multiply is 3/32. So we got 3/8 there. Last but not least is at least for the next 2 days he will drive home. What is probability of it? At least 1. So it's 1 minus twice. So not 1 minus 2 not late. So 2 days, if it's two of them not late, then it definitely have to be 1 or late what? So it's late, not late, not late, late, or late, late. Which means that we just have to take that out. So now we're going to take that out. So we have 1 minus, the late one is 1/4, so it's 3/4 times 3/4. So that gives us 1 minus 9/16, and that should be 7/16. Yes, and that is our 14 marks in our pocket. All right, let's take down this 15 marks as well. So there's a closed cylinder with that piece, and then we want it to, so the warning we give it to you, so pi r square h equals to 20 pi. And so, which become r square h equals to 20. Therefore, you will have h equals to 20 over r square. Yes, and then now show that the material cost is like 6% or something. So I need to use some room here. So we will have curve is 8 meters. So this side, the curve one is 2 pi r h times 8, and then 10 for the top and the bottom. So we have plus 2 times 2 pi r squared times 10. So we simplify that because h is there, so we will be equals to 20 pi r squared 8 plus 20 pi r squared. Getting close now, we have to remove some of those. So 40 times 8 is 32. So we have 32 pi over 32 pi r plus 20 pi r squared. I need a new pencil. So what we're going to do is this is our C. We've got the minimum C. Find the value in terms of I. So we have to differentiate it. So dc dr. So I will have negative 320 pi r negative 2 plus 20 pi r, no, 40 pi r squared. So now we have to just put that equals to 0. So 0 equals to negative 3. I put it back to fraction. That will help us to solve it. And then taking the common factor, the pi out, and multiply the whole thing by pi r squared. So now I got 320 equals to 40 r cubed. Now 8 equals to r cubed, r equals to 2. Not finished yet because they want the minimum c. So we need to put this back in. Therefore, c should be equals to 2 pi 20 pi 4 plus 320 pi divided by 2. So now we have 80 pi, sorry. 80 pi plus 160 pi, which is 240 pi. When I practiced this one, I forgot this bit as well because I'm too happy when I finished the R. So make sure you don't fall into the same mistakes that I made. This is a question I really like because it's like really getting through the concept without telling you all the function. First of all, they didn't tell you the function, so you have to use the clue from there. So the function and the L1 is the tangent of it, which means that they meet at a certain place. So like here. So this is, no, that's not right. But anyway, this is y equals to 3. This is L1. It should be a positive slope. Let's do this one again. So this is L1. This is x equals to 2. And yeah, this is the function somewhere like this. Sorry, didn't see that. All right, so this is the function like this, and then we're going to move on with those. So at f-2, which is the x equals to, which means the gradient here. So f-2 equals to 3, nice and easy. So we put on f2, which is the same thing. So f2 should be equals to 3 times 2 plus 1, get us 7. Now we're going to move on to B. That's the tricky bit here. So to show that the graph G has a gradient of 6, which is G is a composite function of f. So to do this, we're going to assume that that's how I do it. So I put y equals to fx squared plus 1. So now u equals to x squared plus 1, du dx is equals to 2x. Now y equals to fu, so dy du should be equals to f dash u. Now dy dx should be equals to f dash u 2x. Now we put everything back in there, so f dash x squared plus 1, 2x, right? Now x equals to 1, so when x equals to 1, so that become f dash 2 times 2. So we got 3 times 2 give us 6. Wow, I'm amazed. All right, so now we go to the last bit of the question. I need some paper. All right, another piece of paper here. So now let L2 be the tangent of P, and L2 be the tangent of graph G at P, which is, and then intersect L1 and L2. So first of all, L1 and L2 intersect first. So what we need to do is we need to get through the bit of it. So now we have G1, we find G first. G1 equals to F2 equals to 7 because it's moved, shift. Now, which L1 and L2, the equation of it, 7 equals to 6 times 1 plus C. So C equals to 1. Now I got the equation y equals to 6x plus 1. Equation 2, equation 1 is 3x plus 1. We find the intersecting point. 6x plus 1 equals to 3x plus 1. So now throw it to the other side. 3x equals to 0, x equals to 0. Now we find the intersecting point of x, then we need to find y. So when x equals to y equals to, substitute into 0, y equals to 1. Therefore, the point Q is 0, 1. That's why I like it so much. Yep, it's a bit hard, it's tricky for that 16 point, especially the last, how many? Last 7, but yeah, good enough. We get it 7. Well done, people.